We'll go ahead and get started. My name is Andre Fredette. I'm Technical Director of SDN at Red Hat, and I'm here with my colleague Dayavanti Kamath from Ericsson, Principal Engineer at Ericsson. And we've been working together for a while in OpenDaylight and just in general on various things. And then more recently in some collaboration between two projects, the NetVirt project and the VPN Service project. And we're going to talk today about that collaboration, how we think it benefits OpenDaylight and SDN. All right.
Yeah. Thanks. Glad to be here, Andre. Thanks for the intro. If you have any specific questions or any takeaways to talk about, do let us know so that we can just either talk to the slides or directly address your questions and concerns upfront. Thanks.
All right, so there's this is a little outline. We're going to talk some about the benefits of open source, the fragmentation within the SDN solutions, about these projects that we're collaborating on, and challenges and benefits. There. So we're all here at an open source software conference, and many people are contributing to OpenDaylight or using it. And so I think we know a lot of the benefits of open source software. But what we wanted to focus on today were a few of them that we think are benefited by additional collaboration and building better, more vibrant communities upstream on projects. And those are, the benefits are for both us, for developers, the people that are developing the products and software, but also for users. And the ones that we're going to focus on here are quality, feature richness, and vendor choice. So there's saying around the open source communities about eyeballs and software quality. There's this statement, given enough eyeballs, all bugs are shallow. There's debate about that. There's certainly some very high quality commercial solutions, non-open source. But in general, with open source solutions, getting many people looking at it and working on it, is produce very high quality software. And the point that we want to make here, initially here, is that that's true, but not all open source is created equal. There's many small projects, single vendor solutions, and they don't achieve the same level of benefit as a good community project, like OpenDaylight and like I think what we're going to talk about. And it's more than just numbers. It's when you have a solution, an application, and have a good community, what you get is diversity. And I think this diversity does lead to a lot of things. Quality, we have different points of view that Ericsson, Red Hat, other companies, other users have slightly different use cases. We're using it differently, and we can tease out different issues and make improvements. However, working together, we have a lot more capacity for doing testing upstream. For downstream testing is much more diverse because we have our different labs, different customers we're working with, more diverse customer deployments. And however, with all this diversity, we're building on the same platform. And by doing that, it really improves the platform for all of us. I've touched on this a little bit before, but the diversity also gives us feature richness. And we're working on the same base platform, but we have different priorities. And so we'll put up our list of priorities, and each kind of group has their own list. And a lot of it is the same. It's what might differ is really the priorities of which one is more important. And what we end up getting is that we can work on one, somebody else can work on another, and we get more of what we want sooner. The last point that I mentioned earlier was vendor choice. And when you have these smaller, less diverse projects, you get, while it's open source and you get some of those benefits, you end up with different solutions, some of them fundamentally different. And if you choose to go with one of these less diverse products, you end up effectively getting vendor lock-in. Even if it's open source, you're locked into that solution, and the cost to and effort to change to something different is high. Whereas with a more well-established solution, you get, even though there are multiple commercial deployments potentially, as well as the open source, they tend to be pretty similar, at least at the fundamental level, and provides more flexibility to the user. So along these lines, what we have been seeing, and I think this is getting better, which I'll mention on the next slide, but a large fragmentation of the SDN market with many open source projects, many commercial projects, and it makes it harder for users to, well, first of all, you miss out on a lot of the benefits of open source when there are so many different options. But it causes issues with which one to use, and this really slows the adoption. As we start having more concentration of platforms and options and more collaboration, we start to see more of the benefits of open source, and also drives an accelerated adoption. And we had, if any of you went to the keynotes earlier, Neela and others, AT&T and Ericsson, talked about this adoption of OpenDaylight, and it really does seem that OpenDaylight of the open source SDN platforms is really in the lead, both in terms of contributions as well as the real deployments. So on to OpenDaylight. As a community, it's a great community. There's many different companies, many different people contributing. It's a great platform. Many applications have built on this. I'm not really intending for you to necessarily read all of that. This is the architecture diagram from the Boron release and all the different applications that are being done. All of these applications are looking at solving different problems in different ways, and some of them will succeed, some of them won't, but they all serve to really make the platform as a whole much better for everyone. The problem that we were seeing, and why we did what we're talking about today, is that it's not always the case when you look into those applications that it's a great big happy community. There are lots of different. There's some fragmentation of applications, and then in particular the network virtualization. And I say for OpenStack here, but it's in general networking. As of the previous release, Beryllium, there were 6 different options for network virtualization for OpenStack, and options are good, but at some point for this really to take off and to really get better and achieve the benefits, we're going to need some consolidation. And so that's where we were at Beryllium, and we started having these discussions. We'll talk more about them, but as a result, we ended up combining the NetVirt and VPN Service projects into one solution. It's built upon a application coexistence framework called Genius, which provides for the use of allows different applications to work together and to share common data plane capabilities. And as a result, so I'll skip to the next bullet, that in addition to just OpenStack support, this is a network virtualization platform that can be used by other south and northbound devices as well as southbound devices. And we have a network virtualization that can be used by many and can be used for more than just OpenStack. So the reason that we decided to do this collaboration is that the teams of these projects were working together kind of around the edge on OVSDB, OpenFlow, Neutron, a lot of the architecture for network virtualization. We had a similar problem for network virtualization. We had similar solutions, OpenStack, Neutron Provider, working with OVSs. We were building an overlay network. Had some different use cases. The VPN service, they were originally founded as to provide this the BGP VPN support, but as a result had to build a lot of network virtualization capability. NetVirt was really kind of grew out of OVSDB and providing a solution to work with OpenStack. But we had different implementations. So at the end of the day, we'd do all this work together, and then we'd have to go off and kind of do our own stuff. And so at this point, Daya's going to talk to you about what we did, how it to make this work.
Thank you. So we got together intent, and we sort of started from scratch, and we decided, how are we going to go about doing this? And there were multiple ways we could do this. One is we could start slow and get all the different services to work parallelly together on a Genius platform, and then let users pick and choose. Or we could just jump all in and come up with one solution. And the approach we took was the latter, because we figured the sooner we made this the merge of the two projects happen, the sooner, the better it was for everybody, and for all the reasons Andre talked about earlier, which was you get a big community of developers, users, everybody working on looking at the same solution, deploying the same solution, and you can make it help it mature much faster. So how we started about it was we had these two different projects. The OVSDB project had two components. One was NetVirt, which did the realization of OpenStack APIs onto the OVSDB plugin, as well as the OpenFlow plugin. And on the other side, we had the VPN service project, which had some BGP VPN components, as well as some network-like services, and had some semblance of the Genius framework, but it was all sort of built into the same project. It wasn't very decoupled from the VPN service. So that's sort of where we started. And architecturally, the way we decided to carve it out was to create a single network project, the charter for which was to provide network virtualization for OpenStack and other northbound renderers and on different southbound platforms, and have a common Genius framework so that multiple projects, not just NetVirt, but SFC, GBP, and you name it, you can have a common set of services through which all these projects can collaborate in the runtime, at design, and integrate very seamlessly. So we started with moving, splitting out the OVSDB project into the NetVirt and OVSDB components. So the first thing we pretty much did was migrate all the business logic of network virtualization into the NetVirt project from the Beryllium release, and just kept the plugin component, which is the OVSDB plugin, in the OVSDB project. Okay. The next step was to migrate all the business logic from the VPN service into the NetVirt project. And this brought in Genius, so basically between the old NetVirt and new NetVirt, there was a lot of overlap in functionality. And VPN service itself had all the BGP VPN orchestration aspects in it. And then you had the Genius aspects for all the southbound collaboration and app coexistence and service coexistence related aspects. The next step was to split off all the Genius components, decouple them in a nice clean way, and ODL is such a great platform for doing this, right? You have all the MDSAL abstractions in place. So all of this work was done pretty much in like a matter of a week or 2 weeks. Everything working like a charm, no issues, just move the POM files and features around with some great work from Sam and others, and we could do all this, all these huge code migrations in about a week or 2 weeks time frame. So we moved the Genius, all the Genius artifacts into the Genius project, And one of the main reasons behind this is not just NetVirt, but we also want multiple other projects in the ODL communities. From the slide Andre showed before, with this about 1,000 projects, I think, in ODL right now. Just exaggerating a little bit, but there's a lot of different projects which are working in vertical silos. And Genius is a framework that allows some of these projects to sort of work well together in the runtime without needing too much design level interactions and collaborations. So that's sort of where we're going. That's the direction sort of we're going towards. So the next step in this evolution, and this is probably important for some of the existing consumers of NetVirt from the Beryllium release, the old code base is going to be deprecated starting Carbon. It's already in, I would say, support mode. We're not adding any new features on the old NetVirt code base from Beryllium. And the new NetVirt code base is sort of a union of functionalities from both the VPN service project as well as the NetVirt project from Beryllium. So we worked to achieve all the feature parity between various services from a user-facing perspective. All the contracts that the services had with OpenStack, with the southbound devices, they've all been maintained, and they're all sort of living in this new NetVirt project. Architecturally, it's very different. The old NetVirt project was pretty monolithic and had a very fixed pipeline. You might have seen some of the blogs from Flavio and others on how the pipeline for the old NetVirt worked. There's a little bit of rethinking that we've done to modularize all these different sub-services, as we call them, within NetVirt. So that you can have a dynamic mix and match of different services in the runtime. So that allows for a much more scalable architecture, allows for much more flexibility in how your applications get deployed and used in the system. So the new NetVirt, as you see in the picture today, is basically a collection of services, L2, L3, ACLs. They're all individual services that use the Genius framework to together build a unified pipeline through which the packets in your network are going to be processed. And in the runtime, NetVirt has the flexibility to, like I said, to change how these services behave on a per interface or per port basis, right? And then if you have applications from other projects like SFC, which is going to spend the effort, it has already started the effort in migrating to the Genius framework in the Beryllium release, in the Boron release, excuse me. And what you're going to see is in Carbon, it's going to look like yet another service working on your runtime system. And have a very good coexistence with the NetVirt services, so that as a user, when you deploy these services, they're all going to work together seamlessly. This architecture also enables us to sort of have these different southbounds and northbounds devices, add support very easily for new devices. We've already done some of this for Boron. So in Beryllium, for example, the OVSDB plugin was very catered to OVS. We've extended that support and had enabled a new hardware VTEP plugin, which can talk to L2 gateway type devices, VLAN gateways or L2 gateways, right? I think that's, yeah. So the new NetVirt also has very well-defined contracts, MD-SAL, Yang-based contracts for other services to consume each sub-services. And what this enables us to do is, add support not just for Neutron, but additional projects within the community. For example, Uni Manager, right? It can today use the contracts provided by different services within NetVirt and be a consumer of these sub-services. Effectively, what we have achieved is a modular, dynamic, and scalable pipeline implemented by all these sub-services within NetVirt and working seamlessly together. We have the whole community now today working on different aspects of these, but yet at the same time, everything gets tested, debugged, and looked at together, so that we have achieved a lot more acceleration in the features, as compared to how each of the projects were working in their parallel track. And there is a good amount of coexistence between these in the runtime with minimal design coordination. Did you want to take? Okay. So where we are today is, it took a lot of effort, and there were some tremendous contributions made by a lot of people in the boron cycle. The energy was just fantastic. The pace at which we worked was just mind-blowing. So we've completed all the integration activity to get all these services working together. We've put in a lot of code in there to improve the robustness and scale and performance of the system. We've achieved an order of magnitude performance better than how these services used to work in the previous releases. And we've also managed to add new features. We've added the L2 gateway feature, which, as I mentioned before, brings in support for hardware VTEP devices. We've added support for VLAN provider networks on the combined code base. Stateful security groups is complete, and we've started some of the IPv6 implementation. We will continue working on that in the carbon cycle. And we've also completed the NAT functionality during the boron cycle. So a lot of new code and features have gone in, and we're working to continuously improve the feature set, quality, as well as robustness of the project. So that's what I had to say. I'll give it to Andre, I guess, for the next part. And
Thanks, Daya. Yeah, it was a lot of work, and I was, I'm sure we were kind of, when we started out, we decided to take the plunge and just go for it rather than taking the cautious approach. And maybe halfway through, I wasn't sure we were going to make it, but people pulled together and got it done, and so that's been really good. Okay, yeah, challenges. So while doing this, it's great. There were a number of challenges. One of the, a couple of the first ones were we had a whole new set of people that you kind of, we more than doubled the size of the community just between. I'll talk about that a little bit more later, but between the two projects plus additional people joining in. And so you get to know how to work with different people, who they are, what they do, what they, kind of their perspectives, and then learning each other's code and use cases and understanding those. So it takes a little bit of time, and but made a lot of progress this release. Another, you get a lot more feedback than you used to before. You had your community and you did stuff, and everybody was working together, and so as you come to a bigger community, people have different opinions, and really that's the benefit of this. But you have to work through that, determining priorities. In open source, to some extent, a lot of the priorities are just decided by what you want. People want to provide code, and that's what gets done. But there are other things that you have to with as a PTL, and the PTL and the committers have to decide what should be merged and what not. And so work together on that. And we learned to just work more openly and contribute. So but doing this, we've kind of are beginning to think, and we're going to talk about this more during the DDF design forum this week about how we can work together better. But we need to start establishing some more processes. More review policies and getting people involved on reviews. Probably institute kind of a blueprint type feature, process for new features like is done in OpenStack, so that you can have a more review of the functionality and design. So we're working through these and making progress. But people are, I think, willing to do that. It's been huge benefits. It's been amazing. It's a real vibrant community. Have great discussions on our weekly meetings and on email lists and IRC. We do better on IRC. That's one of the things. But that's been good. A real diverse set of contributors. We had took these stats between basically January 1st and like last couple days ago. There were at least 10 different companies that had contributed at least one merge, one commit, and about 100 different individual contributors. And I also, around that same time, I don't have it in here, but there was an email from Tan on the spectrometer project, and I think that on there he said that there were 300 different individual contributors during the boron release. And so that's like about a third of the people that did something, did something on NetVirt. So that's a pretty good contribution. So it really more than doubled. There were these two projects, but then in addition, the Uni Manager project decided to use NetVirt for its network virtualization. So people involved in that project basically jumped on board and helped make it better and adapt it as needed for the Uni Manager. And then others have joined as well. There's some real benefits to other open source projects. We work pretty closely with OPNFV. Right now, there are actually two different NetVirt, network virtualization solutions that are being, supported and tested on OPNFV, the NetVirt-based one, the old NetVirt-based one, and the VPN service-based one. Moving forward, there'll be one. That's kind of nice. From an engineering standpoint, we get more testing on our stuff, more use of it, and then more people to address any issues. We feel we've contributed to other communities that we use, like OVS. The projects are supporting both the kernel-based OVS as well as DPDK-based OVS, and accelerating feature advancement there, like contract support for DPDK and other and just support in general, as well as performance tuning for the OVS data path. Within OpenStack, we feel that together we provide a more complete solution, a viable open source based solution for SDN for OpenStack. And by working together, we're able to keep up with the needed OpenStack support. Plus, the people from within this community, OPNFV, OVS, and OpenDaylight, are contributing into OpenStack as well for NFV, particularly NFV use cases, but other networking as well. And by doing all this, we're engineers, so we kind of have an engineering point of view, but it really provides benefits to users. You get the features you need, you get the quality you need, and with the more eyes on the problem, we get to get things done. And finally, there are multiple, as a result, there are multiple commercial products as well based on this platform. So really, just in conclusion, it's been a great experience. Really, I'm really glad that we did this, and I'm really looking forward to what we can do moving forward as a larger team. A couple things. I'm gonna do a talk with Brady Johnson on the SFC and NetVirt integration, coexistence tomorrow, where we're going to talk about the things kind of the process we went through there and the things we've done. There's demos of this in the Red Hat booth. We're going to do. There's a couple demo theater things going on, and.
Yeah, I just wanted to add, we also have a demo for the L2 game in the Ericsson booth, so please do stop by. We can give you more details on that part as well, and that's part of the NetVirt solution as well.
the we were struggling, or with different solutions. I don't know, struggling, but considering different solutions for this conflict issue. Do you maybe turn your? I think only wanted to. Okay, getting a little feedback there. So yeah, there are a number of the big issue is if you have multiple applications trying to use a single OpenFlow switch. Number one, everybody's got to use table 0. And so we have to resolve conflicts there. And then number two, if you're going to work together, you need to either use different tables or use cooperate in how you use them. And then number three, if you want to work together, you have to figure that out. So Genius really is intended to solve those problems. It has since you're in here, you missed the talk on Genius next door, but it provides a framework for managing that OpenFlow switch. So it's OpenFlow now, but I think there's plans to handle other types of southbounds moving forward. But it manages table 0 and has a virtual port interface where you can register and receive packets, and then it has a central dispatcher that will allow you to dispatch into different services, and then as well as resubmit the dispatcher to work so the services can work together, and then shares tunnels. So I don't know, that's a long answer to your question, but it doesn't specifically manage conflict between OpenFlow rules. It allows individual applications to do their own rules, but work together.
So another question is the VPP is a plan. We have a plan to support the network.
So that's one of the things we're going to talk about on our feature roadmap. Yeah, that's what I had in mind right there. And then netconf to talk to it. But it's been discussed, and it's kind of on the list. I can't say when it would get done. All right. Anyone else? There's Alon back there, who is another big contributor to this whole effort with HPE, and so it's been a part of the great community. Thanks.